Thanks for that intro, David. Thank you for having me lead dev. I'm so psyched to be here. And I realize that I'm the only thing standing between you and the first snack break, and I'm up here with a technical presentation. But I promise there's something here for the people leaders, too. So, technical debt. We all know what technical debt is, right? It's tight coupling. It's leaky abstractions. It makes your projects late. It causes outages in production. It's the way this photo makes me feel. The title of my talk is Good Technical Debt. And you may be wondering, how can this possibly be good? Why would anybody want to create tech debt on purpose? Debt looks a little different in other industries. If you own a home, or went to college, or bought a car, there's a good chance you use debt to make it happen. Debt is a tool. It's kind of like a time machine for value. It helps you get something you want now and pay for it later. Now, I'm not the first person to use a debt analogy for software engineering. Cunningham is credited, we don't like puns, with coining the term. In 1992, he said, shipping first-time code is like going into debt. A little debt speeds development so long as it's paid back quickly. Now, if you follow the saying, time is money, this makes sense. We can borrow time by taking shortcuts, but we have to pay back that time in the future, or those shortcuts might come to bite us. This analogy lets us do accounting with our time. We can track our tech debt balance in terms of time that we'll have to spend on work later. We can also invest time in work done now. Now, what if technical debt was intentional, like a mortgage, instead of an accident? How would you spend a tech debt mortgage? I'm going to show you 3 real examples of good tech debt from a product I helped build at Squarespace. Along the way, I'll show you how you can deliberately take on technical debt to increase the odds of your project succeeding. Now, this talk is going to cover reference a bunch of ideas from books, essays, and talks by other brilliant people who have influenced how I think about technical debt. And we'll only have time to skim the surface of these ideas, but I'll recap them at the end. The conference organizers have told me we'll be able to distribute slides after the conference, so don't worry about taking notes. You'll get links to everything after the talk. So before I go further, I should introduce myself. My name is Jon Thornton. I've worked at some really big companies and some really little ones. And today, I live in New York City, and I work at Squarespace. That's Squarespace's office in the West Village behind me. And this is probably a good time to mention that we're hiring engineering roles at all levels. Squarespace is well known for its website building software. And in 2017, I got the opportunity to join the team that was building out a brand new email marketing product at Squarespace. Here's the system diagram of our MVP. It has a WYSIWYG editor to make beautiful emails, mailing list management, integrated analytics, and a backend capable of delivering billions of emails quickly and efficiently. Pretty much everything you'd expect in a modern email service provider, and our team got to build it from scratch. And I'm really proud of what we shipped, but it was full of tech debt. Now, it's not full of tech debt now, to be clear, maybe just a little debt. But we've rewritten all of the things that I'm going to show as examples in this talk. But the first version of what we shipped had a lot of things that we knew we'd have to address in the future. This was on purpose. Just like Cunningham said, we were using debt to speed development intentionally. And we were trying to go fast for a really good reason. Assuming that we could get our product into users' hands a few months sooner, we'd get a head start on growing our customer base that would never go away. That green shaded section represents the extra revenue from shipping 2 months sooner, and that area extends to the right forever. This means that when we're building something that accumulates users or value over time, ship sooner once, and you'll reap the benefits of it forever. So we used debt to speed development on our project and ship sooner, and it worked. We shipped our product to end users in a little over a year, and just as importantly, it didn't turn into a maintenance nightmare 2 years later. One of the keys to our project success was telling the difference between good debt and bad debt. When we cut the wrong corners or spend time on things that don't matter, projects get bogged down in bad debt. Luckily, good tech debt usually looks the same, which can make it easier to identify and sort out from bad debt. It involves unblocking forward progress by deliberately building something that's overly simple. So let's get into our first example. In this case, under abstracting or not building abstractions, hardcoding things. Hardcoding means that some part of the app's configuration, content, or other data is written right into the source code, and in order to change that data, you need to edit the source code, rebuild the project, and do a deploy. And you can probably think of some things in your project that are hard-coded that you wish weren't hard-coded. So why would we want to do this on purpose? Here's an example. Our app's dashboard had this thing called a hero image that we used to promote new templates and features. We had a winter holidays themed hero image coming up, and our product manager wanted this to go live the day after Thanksgiving. Now, we could have solved this with a manual update and a planned deploy, but something about planning to deploy on Black Friday felt like a really bad idea. Another approach could have been to build out a database-backed content management system with a UI, which would allow the product managers to change their hero image whenever they wanted. Now, it's just a form with one field and a button. This couldn't be too hard to build, right? And unfortunately, this approach comes with hidden costs: additional front ends, validations, data to manage. Maybe permission and authentication to limit who updates the hero image. We'll probably need to set up some monitoring and alerting to make sure it's all working correctly. Now let's imagine we integrate the CMS with the rest of our application. That's how integration works. You just smush the diagrams together, right? Now, this diagram makes me a little concerned because the CMS system for updating the hero image has nearly as many components as the rest of our application. Keeping all those components around isn't free. It's important to remember the problem that we're solving when evaluate the solution. All we're doing here is updating one very specific image once. We probably don't need most of the functionality that a CMS would provide. Jeremy Miller sums up the problem perfectly in a tweet. Unused code isn't just wasted effort, it also gets in your way. Like, any of the points where our application integrates with the CMS are going to get more complicated. We'll have more maintenance work in the form of security updates, and if we ever want to move to a different platform, we'll have more components that we have to bring along. The hidden costs that come from solving problems that we don't have yet are the bad kind of tech debt, saddling future developers with more maintenance work than a feature is worth. This kind of tech debt is almost always unintentional. We think we're doing our future selves a favor, but the problems we anticipated never actually come to be. Some of you may have seen this comic. I'll pause for those who haven't. So there's an old extreme programming slogan, "You aren't going to need it," which can be shortened to YAGNI. And the point is, most of the time, people tend to misjudge the future problems that will need to be solved. This is an innate bias, and it takes conscious effort to overcome. My team on the email project latched onto YAGNI as an appropriate interjection in scoping conversations. If someone said YAGNI, it meant that they wanted to call out that potential bias and dig into whether the thing we were talking about was really needed. So getting back to the example of changing our app's hero image, we YAGNI'd the CMS. The hero image changed infrequently, and we didn't have any other content that was going to change that often. A CMS would have gone mostly unused and gotten in our way. So instead, we solved it with a small, hard-coded if statement like the one behind me. This solution was great because it was quick, easy to build, and very easy to understand. Now, there were a couple questions that we had to answer to ensure that our lack of abstraction wouldn't turn into bad debt. Avoiding abstractions brings the biggest benefits when it helps us avoid building a big new thing. If our app already had a nice, featureful CMS that we could just plug our hero image into, then using it wouldn't have added much cost to our application, and hard coding probably wouldn't have made that much sense. One drawback of hard coding is that only people who know how to commit and deploy code can make changes. For example, if the PM is the one who decides when their hero image changes, but they can't update the code themselves, they're going to have to get an engineer to help them, and that's going to cost another person time and introduce an additional coordination overhead. So to avoid introducing this overhead, my team used the test. Does the person who makes decisions about the hard-coded thing know how to use Git and deploy code. Another drawback of hard coding things is the increased likelihood that we'll have to release small changes quickly or unexpectedly. If there's bad tech debt in our deploy pipeline, and it takes a lot of effort to release new changes, this could cause a lot of frustration and wasted time. So our team had a set of corners that we would not cut, and keeping the build fast was one of them. This was very much influenced by the practices from Jez Humble's book on continuous delivery. If it hurts, do it more frequently and bring the pain forward. See, sometimes you do some task and you're like, ugh, that wasn't fun. And then you don't do it again because you don't have to. And then sometimes you find yourself saying, ah, shit, I have to do that unfun thing yet again because you don't have a choice. Anything my team found ourselves doing frequently or depending on, we prioritized making those things awesome. That meant doing them more often and approaching them like a skill that we wanted to practice. Having a solid foundation with a fast build and good observability made it much easier to benefit from debt in other parts of our application. Now, the next example of good tech debt also depends on having a solid foundation to pull off correctly. Unscalable is usually used as a put-down, but code that doesn't solve scaling problems has its uses. The email app that my team was building needed an analytics feature. We knew from user surveys and competitor research that users expected analytics, but it was really hard to get a clear picture of what exactly we needed to build because we got slightly different answers from all the users we talked to. Since we were unsure about the right approach, we didn't want to invest too much. When building something new, it's important to remember that we're experimenting. Just because a product manager wrote it in a Jira ticket doesn't mean that's actually the right thing to build. Failure is a normal part of innovation, and we can't get too attached to our ideas. So that means not spending all of our energy on every idea, and instead calibrating our investment to the odds of success. Annie Duke was one of the world's best poker players before she became an author and decision consultant. And her brilliant book, Thinking in Bets, explains the need to acknowledge uncertainty and incorporate it into our decision-making. A decision is the result of a good process. And that process must include an attempt to accurately represent our state of knowledge. That state of knowledge, in turn, is some variation of I'm not sure. You see, we're socialized to avoid saying, I don't know, or I'm not sure. And we regard those expressions as vague, unhelpful, or even evasive. But getting comfortable with I'm not sure is a vital step to being a better decision maker. We need to make peace with not knowing so that we can approach the uncertainty in our work with open eyes. The game of poker is all about odds and uncertainty. Expert players memorize the probabilities for different combinations of cards to help them decide how to spend their poker chips. And most of the betting happens before all of the cards have been revealed, which forces decision-making with incomplete information. You know who else has to make decisions with incomplete information? We do. As engineers, we're gambling with our time. And we need to stop seeing requirements as binary, as either happening or not happening, and instead think critically about uncertainties and probabilities. Doing this will allow us to adjust our bets, our investment of time in a task or a project, to match the odds that we're solving the correct problem in the correct way. Doing this helps us avoid wasting too much time on the wrong thing. And in the case of my team's email analytics feature, we didn't feel super confident about our odds. So we decided to make a relatively small bet by implementing the first idea that came to us in the simplest way possible. Now, it's not worth going into the technical details, but what we built here was very simple and very inefficient with the database. And no one on our team expected this to scale for the millions of users that we were building for. But it worked perfectly fine for hundreds of users, and that was good enough to unblock us for a beta launch. We had confidence in this approach because we spent some time to understand the limits of what we built by running load tests. This helped us have a better idea of when our implementation would run into problems so that we could make space in our roadmap in the future to make something more robust. Now, this load testing work was a risk. If we had spent too much time on it, we'd be making a larger bet than we'd actually intended. We were fortunate to have a load testing framework that made this really easy, but if we didn't, we might not have used TechDebt here. We put extra care into the monitoring and alerting for this feature, again, to help us predict when we'd have to invest more time in making it scalable. And finally, our team discussed what a more scalable version of this feature might look like. We didn't build it right away, but we kept the plans in our back pocket so we could move quickly when it was time to build more. And the wild thing is, our bet turned out to be a winner. Not only did our first guess satisfy our users, but the feature scaled way better than any of us expected. In fact, this unscalable code supported hundreds of thousands of users, and it was in production for years before we had to replace it. And the thing is, if we had built the more robust version first, our project would have shipped later, and we never would have known that the simpler version could have worked so well. See, good tech debt isn't all about managing and mitigating downside risk. It can also help us be more open to good luck. Now, at the beginning of this project, we were starting with a long list of things that we knew with pretty high confidence that we'd have to build in some form. We'd done a lot of user interviews and competitive research, and that clearly told us there was a list of features that everyone expected in this kind of product. There's definitely a waterfall element to this project. When you're starting with a long list of requirements, it's pretty hard to avoid building a long timeline. Now, the problem with long timelines is that I'm a terrible psychic, and I'm pretty bad at predicting the future. Any 8-month project plan I make is probably going to be wrong. And our industry tries to avoid waterfall development because it comes with risks. Typical waterfall development involves some amount of upfront work before you finally get something valuable at the end of the project. The danger comes from getting the estimates wrong. It's rare to take on a project no matter the cost. More often, we're approaching projects like investments. So something that's totally worth spending 3 months on might not make sense if it takes 3 years to do. This diagram shows how a project starts off with an expected cost and an expected benefit, but runs the risk of blowing through that expected cost and ending costing more than the project was worth in the first place. My team at Squarespace wanted to avoid this trap. Our company leadership had told us they wanted us to build something in 12 months, and the last thing we wanted to do was get to month 11 and not be sure we were close to shipping. Now, we were a small team, so we couldn't do everything in parallel, which raised the question of where do we start? If we know that we're going to have to build all of these components anyway, does it matter where we start? Astro Teller, the CEO of Google X, created the perfect metaphor to answer this question. So hear me out. Imagine our product manager comes to us and they said they had a brilliant idea last night for the perfect product. A monkey on a pedestal reciting Shakespeare. Anyway, monkey on a pedestal reciting Shakespeare. Don't ask me what the business model is. Let's just assume the product manager was really convincing and we're going to help them make this thing happen. So where do we start? Training the monkey or building the pedestal? We could start with the pedestal. It seems pretty straightforward. We've all seen examples of pedestals. Like many bearded software engineers of a certain age, I happen to have a woodworking hobby. I could help build a great pedestal. Might as well start with the low-hanging fruit, right? It gives the team a sense of momentum, something to show off to our managers, and once that's rolling, we could train the monkey. Now, the problem is, show of hands, who here has trained a monkey to read before? Yeah, me neither. We have no idea how long it's going to take to train the monkey. Heck, we don't even know if it's possible. And that puts us at risk for falling into that trap I showed earlier. Our project only delivers value if we can train the monkey to recite Shakespeare. And if it turns out that that's impossible or too expensive, we've just wasted our time building a pedestal. The order that we build things in matters a lot. It's better to train the monkey first, before we spend any time building the pedestal. If we succeed, then it's straightforward to build the rest and get our project across the finish line. And if we fail to train the monkey, then at least we found out sooner than we would have if we built the pedestal first, and we can take that saved time and go do something more productive with it. So let's imagine that we start with training the monkey, and it turns out that we're successful. Our simian collaborator is quoting Hamlet, and we've published several important papers on primatology along the way. And one day, we're in the office, and someone from another team walks by and says, "Yeah, that's cool and all, but can he do it on a pedestal?" This raises a genuine concern. We haven't built our pedestal yet. What if the monkey's afraid of heights? Now, the lean startup, popularized by Eric Ries, offers a solution in the build, measure, learn loop. It's a simple framework that helps you efficiently gain confidence that you're solving the right problems correctly. The idea is we come up with a hypothesis, we build an experiment to test that hypothesis, and then we use the data from that experiment to help us decide what to do next. And along the way, we learn whether our project is on the right track. The more realistic we can make our experiments, the more accurate the data should be. It's like surveying users versus studying what they do in the real world. Like, we could ask the monkey if he could perform on a pedestal. You know, we trained him to speak. Might as well take advantage of it. However, I'd trust the data more if we actually saw the monkey performing on a pedestal. Observations make better data for experiments than surveys if we can get it. And the problem is, the pedestal that we're planning to build for this monkey is going to be pretty epic. We know how we're going to build it, but it's still going to take a while to make. It's the world's first talking monkey, after all. It deserves a good pedestal. The problem is, we don't want to spend all of this time and money making this pedestal only to find out that the monkey's afraid of heights. But for the purpose of our experiment, we don't need the real pedestal. We just need something for the monkey to stand on. We could fake out the pedestal with something cheap, like a milk crate. This idea is something similar to something my team did while building the email application. Now remember, at the start of the project, we had to decide what order to build things in. Following Astro Teller's advice, my team and I made a list of all the components, and we sorted them into monkeys and pedestals. This helped us form opinions about how to sequence our work, and we decided to build the email editor front end first. It was our biggest monkey, so to speak. There we go. Now, we knew we needed the email editor to be really awesome for our project to succeed. But none of us had ever built something like this before, and we weren't at all confident that we'd get it right on the first time. We wanted to work on it first so that we'd have the option of throwing everything away and starting over, which we actually did a few times before we got to the point where we were feeling good about it. The problem was, it was just a feeling. See, we hadn't built email sending yet, and so no one outside of our team really tried to create an email with this new editor. Why would they? And the problem with this, it's kind of like when you only show your writing to your mom. You need outside feedback to know whether it's actually good. See, our team was only guessing that we had built it correctly, and we needed to observe some users to learn from. And our email editor with no sending was kind of like that monkey performing without the pedestal. So our team had scoped out email sending as a big pedestal. The final product needed to be capable of sending billions of emails quickly and reliably. Fortunately, several members of our team had built something like this before, so we weren't too worried about it. Still, we didn't want to wait that long to find out if people would use our editor to send email. So we knew that our coworkers on other teams could make good test users for the email editor, so we asked ourselves, what's the simplest thing that we could build to make our editor useful to our coworkers? And this is where good tech debt comes in. See, the finished product was going to need the capability to send billions of emails, but we didn't need that capability right now. For our experiment with coworkers, we'd only be sending a couple hundred emails, and our coworkers could tolerate a little bit of unreliability. And something that sends a handful of emails unreliably is way easier to build than something that sends billions of emails reliably. So we realized that we could quickly build the unreliable sender now, unblock getting feedback to our editor sooner. And then later on, we'd throw away the unreliable sender and replace it with the real thing. Now, on paper, doing this extended our project timeline because we were writing more code. Most engineers try to avoid throwaway work for this reason. But it massively reduced the risk on our project by helping us get real-world feedback on our editor sooner. Maybe in a perfect world, that throwaway work was wasted time, but in the real world, it saved us costly rework later in the project. The idea is a little bit like construction scaffolding, where you spend a little time building a temporary structure, and that temporary structure helps you build the real thing, and then you tear down your scaffolding. Your scaffolding might be a milk crate for a monkey to stand on. In software, scaffolding code stands in for something more complicated, usually for the purpose of experimenting, and then gets replaced with the real thing later. This goes back to the idea that debt is a time machine for value. Throwaway code can help us adjust the order in which we build things so that we're not stuck building things before we have a way to validate them. And I swear, the email sender that we built for our experiment really was this dumb. It didn't even have exception handling. But sometimes dumb is OK. Even though everyone on my team was a little horrified by it, it was good enough to get some coworkers regularly using the app, and we actually later felt confident enough to demo it on stage at a company all hands. But the code being bad was also a benefit, because none of us felt bad later when we threw it away. And our coworkers gave us amazing feedback. We discovered bugs and missing features in the editor, and we made a bunch of changes to the rendering code. And we spent less than a week building to unblock getting that feedback. We iterated faster. We were able to avoid context switching because we were still fresh in the mindset of building the editor. And when it came time to build the real email sender, we were able to do it with some lessons learned from building the throwaway code. We got valuable information for very little work now. This is a great use of debt. Now, several self-imposed guidelines helped the implementation of our throwaway code go smoothly. We committed to our estimate. If we couldn't build the throwaway sender in the estimated time frame, it was a sign that we were taking on too much complexity and needed to rethink our approach. We'd be making a bigger bet than we intended. Good tech debt only makes sense when it helps us go faster. If we find ourselves spending a lot of time writing throwaway code, maybe it would have been better to just build the real feature. And the underlying point here is that the team needs to be pretty disciplined with project management for throwaway code to avoid turning into bad tech debt. The ability to estimate the time or cost of work accurately is a must for using this tactic safely. Our email sender scaffolding was designed to be thrown away and communicated as such right from the planning stage. The code was well contained behind an abstraction, and we took care to limit which parts of the app integrated with that throwaway code. Now, designing your code to be thrown away is a good habit to get into regardless of whether you're planning to throw it away or not. It'll help us come up with better abstractions. In this case, because it was throwaway code, we didn't waste time nitpicking over small details in the code review, and this made the scaffolding even cheaper to build. We understood the scaffolding's limitations and avoided using it in situations where failure would cause harm. We'd be going deeper into debt if the team had to spend time cleaning up errors or investigating incidents. So we thought about all the things that could go wrong, and we made a list of supported use cases that we shared with our test users. Finally, our product managers and other stakeholders knew that we were deliberately taking on tech debt. In fact, we bragged about how bad the email sender was, and in the process, we made sure all of our stakeholders knew that we'd need to invest time later to build the real thing. Awareness is a key ingredient for good technical debt. Repeating yourself is key because stakeholders tend to be a little forgetful when it comes to tech debt. Those of you who've been managers are probably familiar with the idea that you need to repeat something at least 3 times for people to actually hear it, and this totally applies here. If a non-technical teammate or a stakeholder sees the email editor successfully sending an email, they might very understandably think that we've already built it and we can move on to the next thing. And this miscommunication and the surprise that it creates the next time the team does planning is one way for good tech debt to turn into bad debt. And that need for awareness points to the most important difference between good and bad tech debt: intention. One common trait for all good tech debt is a lack of bad surprises. We can't predict the future, but we can manage the kinds of surprises that we encounter. And we achieve that through the concepts and tactics that we just talked about. We covered 3 common ways tech debt can be used to save time. These aren't the only ways to use good tech debt, but they've been the most common for me. And we covered some reasons why tech debt can be beneficial to your project. Even when you're not using tech debt, these concepts will help you make better scoping and planning decisions. And as promised, here are the links to all of the ideas that I just referenced. We covered a lot of concepts very quickly, and my talk is just skimming the surface of these ideas. So you'll need to dive deeper into these books and presentations, and I hope my talk got you interested enough to check them out. Not yet. Just a reminder why any of this matters. Time is our ultimate currency, and we can never get back time that's wasted doing things that don't matter. Many of the things that we build accrue value over time, whether that's revenue or positive impact on the world. Good tech debt will help you ship sooner by focusing your time on the things that matter. So I hope I've given you some ideas that will help your team go faster and inspired you to think about how you can do more by building less. That's my talk. Thanks for listening.